to a new video from Flash Jazz Cat, and here we have an Atari 800XL, and yes, it has been seen on the channel before, and yes, it's still here, but it is going to go home shortly, and I thought it would be a nice thing to make a little video giving a broad overview of what it actually does, since previously I've covered nothing but problems really. I will touch on some of the problems in this video, since it's part of the story and it explains why the machine's still here more than 2 months after I started to build it. But yes, I'm going to touch on each of the upgrades in the machine, partly for the benefit of its owner, but it may be of wider interest to others as well. But stick around anyway if you're interested in highly upgraded Ataris, because there's a lot of goodies in this machine, and we're going to touch upon how to set them up and what you can actually do with them. So let's tear right into that. Now, this machine is, as I said, it's an 800XL, it's an NTSC machine, and I've actually had it here, well, in the two different properties, because we moved house in the interim. This machine arrived at the old property not long before we moved out. So in the interim, while we were moving into this house, obviously, and anybody who's moved house knows how long that takes, and the situation was hardly helped by my injuring the finger on my right hand, the middle finger, which had to be splintered up for 3 months. During that time I was also working on this house, trying to do things that I thought would be better done before we moved all of our stuff into the house, because obviously when the house is full of stuff, it's harder to get things done without making a tremendous mess. So that's what we're doing. So when the time came to actually open the box with this machine in it, it was actually January of 2024. So the machine had already been in my possession for about 5 months by that point. Now, the remit for this particular assignment was to simply fill an Atari 800XL full of the most powerful and capable upgrades, well, also happened to be the most expensive upgrades, in the Retro Lemon shop. Now, the client went directly to Jakob at Retro Lemon when it came to actually speccing the machine up. So by the time I came on board to actually do the work, as it were, referred kindly by Jakob himself, the actual bill of materials, as it were, what was going to go into the machine was pretty much cut and dried. And of course I was moving house, I was about to move house at the time, so I didn't really have time to start asking a lot of probing questions, even though with hindsight I rather wish I had. So if we pop the lid off, I haven't actually screwed the top of the case down yet, so we'll whip the lid off the machine and have a reminder of what's actually in it. Now, one very interesting thing about this particular machine now is that compared to the previous well, 2 videos about it, this is actually a different motherboard, but I'll get into why that is later on. So we have now we have VBXE, we have Adaptus and Rapidus, we have Ultimate 1 MB, and we have PokeyMAX and SAVO. Now I'll go through each of these in turn. We'll start at the top corner, we'll work our way clockwise around the board. The Rapidus is a CPU accelerator card. It has on board a WDC, I think it's WDC, 65C816 processor, which is a kind of a hybrid of a 6502 or 65C02 specifically, I think, and a 16-bit or sort of a pseudo 16-bit CPU, which obviously has a compatibility mode with the 6502, so it can run in native mode and it can run in, if you like, emulation mode. It won't support, I don't think, in emulation mode, things like illegal opcodes, undocumented opcodes on the 6502C, which is the Sally chip, which is actually over here now. But in all other senses, it should be broadly compatible with legacy software. Now, the Rapidus, in order to implement a belt and braces approach to compatibility, I guess, also has the 6502C, the Sally CPU, on board. So there are 2 modes of operation on the Rapidus. We're either using the 65C816 processor in emulation mode or native mode, where you can switch between the two in software. It's always going to start up in emulation mode. Or we're using the original 6502C processor here. Now, as well as that, we have a ROM on the board, which carries the firmware for the device, and it carries the 65C816 operating system that was written by Draco30 Conrad. It has, I think, 16 megabytes of RAM. I'm assuming the RAM is a 16 megabyte chip. I think 14 megabytes is practically accessible, but I might be wrong about that. For some reason it sticks in my mind that that's what it is. This is our JTAG header here for programming the CPLD. I think it has the same Xilinx CPLD on the back side of the board that you'll find on the Ultimate 1 megabyte, or a similar version thereof anyway. I remember writing the JED file to this board, and it used basically the same arrangement. We've also got a header here, which I don't think it's been used for anything practical, but it's kind of, I suppose, a parallel bus or a DME port, which hasn't been exploited yet, but I guess you could put all sorts of things in there, like hard disk interfaces or something like that would have direct connection to the memory on the Rapidus. I can't remember offhand how much ROM is actually on this chip. The other thing about this board is that when we're running in Rapidus mode, so using this CPU, it runs at 20 megahertz, which is obviously considerably faster than the 6502C. And when we go into classic mode, we use the original CPU, the 6502C, at 1.79 megahertz. So you could, if you wanted to, and if the software was fully compatible, which probably most of it is, run in Rapidus mode, but run the CPU, the 65C816 CPU, at 20 megahertz, but in compatibility mode. So then you'll simply get a compatible system that simply runs much faster. Now, only code that sits in the SRAM on the Rapidus itself will run at 20 megahertz. Obviously, ROM code on other parts of the system, cartridges, etc., that all must be tied to the original system clock, because that's the speed the bus runs, and we'd have all sorts of problems with response times and such like, and access times if we tried to run cartridge ROMs and the Ultimate 1 megabyte, etc. If we tried to extract code from that and run it on the CPU at 20 megahertz, it simply wouldn't work. So it's quite a complex device. And as I have in the past mentioned, one or two little problems that we've had when it comes to compatibility with the Ultimate 1 megabyte, VBXE, etc. They're fairly minor for the most part, can generally be addressed by installing a 74F08 chip in place of the 74LS08 chip. And those problems that can't be overcome by doing that, probably, well, I'm guessing, my opinion, it's probably something that could be addressed in a firmware update on the Rapidus itself. Maybe it couldn't, but you tend to experience unusual behavior with system reset. This particular machine, when Rapidus is taken entirely off the bus, it requires 2 hits of the reset key to actually get through a warm reset. And most of the time, if not all of the time, well, all of the time in my experience, when you run the Rapidus in classic mode, so running the original CPU but with the Rapidus enabled, you'll occasionally get a cold boot when you press the reset key. That's been the case for the past 8 years or so since I've seen it. Apparently not all machines do this in a consistent manner. Every machine I've had has tended to do it fairly predictably. But other than that, it's a very interesting system and very, very powerful. And if we get time later on, I'll show you a couple of interesting things that we can do with the Rapidus board. So moving on to the PokeyMAX board down here. Now this sits in the Pokey socket. Now what this is a CPLD or FPGA implementation of the Pokey chip, but it's got so much more than Pokey on it. It's got a subset of a plethora of features. This is the PokeyMAX 2 board. The PokeyMAX 3 has much more space on the chip. It has a lot more I/O pins on the back, so you don't have to pick and choose which feature you want. But we've got dual Pokey, quad Pokey, SID emulation, Covox, we've got PSG, some sort of synth stuff. Half of this stuff is completely over the top of my head because I'm not really big on the sort of retro music scene, chip music stuff, but this device can do a whole load of clever stuff. And of course, with the scarcity and the price of original Poke chips now, this becomes a fairly viable alternative, although this particular board cost 120 quid or thereabouts, so they're not particularly cheap. Even these can be quite scarce. I don't think they're readily available, but I've got a PokeyMAX 3 in my 600XL. Very happy with it indeed. It's a kind of a set it and forget it device, and of course we've got a plug-in on the Ultimate 1MB, which allows you to set this device up, although it does come with its own configuration tool written by Mark Foft, as you'll know him, who wrote the firmware for this thing. Marvellous device, absolutely great. Now if we move to the front of the machine here, what we've got down here is the Adaptus board. Now the purpose of the Adaptus board is to move the CPU socket towards the back corner of the XL machine. The reason being that because the keyboard hangs over the CPU socket on the XL machine, there's no room to piggyback the Rapidus board at the front of the board. Now this isn't a problem on the XE machine where the CPU socket's at the back of the board, although it does necessitate the use of a nasty stack of precision sockets underneath the Rapidus to bring it over the top of the ECI housing at the back of the machine. But in any case, on the XL machine, so 800XL and 600XL, if you could manage to fit one in a 600XL, which would be certainly a fun project to attempt. The Adaptus board was designed, and as I say, its purpose was to simply relocate the CPU socket to the back of the board. It attaches in the SRAM socket, or in this case the Adaptus is actually soldered to the board for reasons of vertical clearance. But anyway, those signals that aren't on the operating system ROM socket, of which there are a few, are simply taken via this ribbon cable and sent over to the back of the machine. Now there's also obviously there's a CPU socket in the Adaptus board, and that's what the Rapidus plugs into, but there's also a pass-through socket for the 28-pin ROM chip, or in this case the OS ROM cable going to the Ultimate 1MB, which we'll actually come to last because we started over here. So that's the Adaptus board, so that's part and parcel of the Rapidus in this particular machine. Now if we move over to the left here, we've got the VBXE. Now the VBXE's been around for quite a long time. Its main purpose is to provide RGB output, so that's 15 kHz RGB output, although there is a deprecated VGA core for this, which requires a 28 MHz crystal. On an NTSC setup you can run a fairly compatible VGA output on the back of the machine, but this is just stock. I tend to prefer this. It's got nice character, it's got nice retro character. The 15 kHz RGB signal, that's completely compatible with, for example, SCART, which we have over here in the UK and Europe, or older 15 kHz monitors like the Commodore 1084S, etc, etc, or the Philips CM8833 Mark II. They'll all display the picture that comes off this board. Now it's not just about improved image quality via RGB. Of course, because the VBXE actually sends the videos straight off the board, it has to emulate GTI here, which it does. But the VBXE also provides a hardware 80-column text mode, which is something the Atari was always lacking. High resolution up to 640 by 200 or 400 with interlace. Graphics, I think up to 4 colours with that mode, or 320 by 200 at 256 colours. I'm probably butchering the specs actually. You can find them. I'll link to the documentation. And a hardware blitter. It's got VRAM. It's got 512K of VRAM on board. You can run a core on the VBXE that will implement a port B 256K, so 320K in total RAM expansion. That robs half of the VRAM, which you would normally use for the video data. But in normal use, you've got half a meg of VRAM, and obviously that's accessed via an access window in the memory map in the base 64K, so you can feed data into that VRAM, and you can use the blitter to move the information around and do fancy visual effects. Because we're dealing with quite a large amount of memory and quite a large amount of data when you consider the size of a, say, a 256 colour 8-bit bit depth image. So that's VBXE for you, and it's, as I say, it's quite a mature product now, and most of the time it's just used for the improved video quality and the 80-column text mode maybe, although there have been quite a few demos written for the board, and of course we've got the Popeye game, and various games are starting to come out for the board now. which is nice to see. So if you buy one of these now, you can find a reasonable amount of software that will exploit it in one way or another. And of course, Spartados X comes with drivers to provide 80-column text, etc, etc, etc. Now, if we move up to here, this is the SAVO board. Now, this board is quite a bit of a time saver for me. What I used to do, and what I normally do, is put a DIN 13 connector, which is sort of compatible in character, if you like, to what you see on the Atari ST for the RGB output, and that goes in place of the RF modulator, which has been removed. Now, this board simply has mounting points compatible with the RF modulator, and it basically uses a Sega Saturn, a small DIN connector at the back here, which means the idea of this is that you don't have to change the case on the back of the machine. It's in the exact same position that the RF connector used to be, which is quite a nice idea. It's not perfect because the connector tends to be set back from the rear of the case quite a lot, so you might have problems firmly seating the cable, but I think they've trimmed back the shroud on the cable for that purpose, so that you can actually get the thing to make proper contact when you plug it into the back of the machine there. I've added a little bit of solder to the anchor points on the side of this connector as well, because it isn't the most solid thing. The board's quite thin. It would also be nice where these solder points here, it would be nice to see them attached to the flood-filled ground with those little crosshair traces, rather than just being vias in the middle. These, you really need to use a lot of heat to solder these properly because of that, because obviously the heat's sinking straight into this flood-filled copper here. Whereas if you just had the via attached to the copper plane with the little sort of they look like little crosshair traces that you see on some things, that would make it a little bit easier to solder. But then again, they're very robust and you're unlikely to pull a via out when working with this thing. So this board, it's set up, it's got labelling on the silk screen, and you can put a pin header here as I've done, and all the signals from the VBXE go there. You need the RGB control line, which is just 5 volts taken straight off the board. You've got the composite sync coming in, and the stereo audio as well, coming from the PokeyMAX, and that's that. So finally we move back to the 12 o'clock position here, and this is the Ultimate 1 megabyte, the venerable Ultimate 1 megabyte that's been around since about 2011, I think now, or earlier. And this is another one of the devices that I've written firmware for, replacement firmware as it was. It's probably more or less ubiquitous now. This is a 1 megabyte RAM upgrade, although it sports 4 different modes. It's got stock modes, so for example, if you had 128K 130XE, stock mode would be 64K base RAM plus 64K extended RAM. We've got 320K mode, which is 64 base RAM plus 256 extended RAM. We've got 576 mode, which is 512K of extended RAM plus 64K base RAM. And we've got 1088 mode, which is 1 megabyte of extended RAM plus 64K of base RAM. This machine requires the base RAM of the machine. It does just have the 1 megabyte on the chip, so you need working base RAM. You'll notice that there's no base RAM on this machine, and that's because it also has the device I actually forgot to mention. So this whole orderly tour of the board has gone all to hell already. Underneath the Rapidus here, we've got the SRAM board. So the SRAM board simply replaces the stock 64K base RAM on the system. That's all it does. It has a couple of helpful little headers on the side. There's one for the IRQ line for the VBXE, but it also requires a connection to CAS inhibit to turn off the existing stock memory bus, and external select, so that it knows when to unmap itself if an external device wishes to do so. So that's why there's no base RAM on the machine anyway. But in any case, whether it's SRAM or whether it's DRAMs, the Ultimate 1 megabyte does need the base RAM of the machine to be present. So what else does the Ultimate 1 megabyte have? Well, it has a battery-backed real-time clock chip down there, DS 1705 if I remember correctly, 1703. There's the JTAG header. That's the ROM chip. The ROM chip is 512K. That includes the BIOS, the PBI BIOS and the loader on the device, plus 4 different operating systems, Spartados X and XEGS 8K game slots. So we've got loads of ROM, we've got loads of RAM, and one of the nice things that this is capable of doing is implementing a PBI device as if it was plugged into the back of the machine and had its own firmware. And that enables, in combination with the Side 3 cartridge in this case, for this cartridge to act not like it was something plugged into the cartridge port, but rather more like a host adapter, a hard disk host adapter that was plugged into the parallel bus. Which means you can boot the operating system from it, you can boot DOS from the hard disk or the SD card in the cartridge, which is nice. So that's taken us all the way around the board there. So what have we got all together? We've got Rapidus, Adaptus, SRAM. So seven different things if we include the SAVO there. Now there were originally going to be 8 devices in this machine, and the other one was the AKI board, the USB AKI. Now the purpose of this is to allow the use of an external USB keyboard. Now one of the first things I did with the original motherboard that was in the computer that I was sent, that arrived in a bag of old jumpers and t-shirts and wasn't in the best of shape. If you go back and look at the other video, you can see how I renovated the case and fixed the keyboard and cleaned things up generally. But the first thing I did, because it's nice to get these messy jobs out of the way first, was to replace the old RF channel switch with a board-mounted USB connector for this device. And you can see the hole in the back of the case is a bit bigger than it normally would be, precisely because I made it large enough for the USB connector, but you see it's not there anymore because I took it away. Now the reason I took it away is because this sits in the Pokey socket, like the PokeyMAX. Now normally you would have either the you'd normally have the Pokey chip sitting in this socket on top of the USB AKI board, or in this case we had to plug the PokeyMAX into the socket on top of the AKI board. Now it cleared the back of the keyboard fine, but I had previously had problems with AKI boards in, well, last year, with various bits of functionality that weren't working. It wasn't fully compatible with the Atari XEGS. I was sent an updated firmware that turned out not to work with NTSC machines, and of course this is an NTSC machine. So I spent a lot of time trying to get this to work in this computer. And that involved basically waiting for suitable firmware to be produced, which it eventually was. And it was quite recent, actually, last week, when I got firmware that was pretty much finished, ready to go off to the manufacturers, because there's a new version of this board as well. It's got a black PCB and it's got a bit more RAM on the chip, so it can do more stuff. Now what eventually I found is that there's a compatibility issue between this board, the PokeyMAX, and the USB AKI, unfortunately. And I have informed FOFT about this as well, and I've told the people who produce the AKI. There's no fix in sight. I don't know which party would propose to try and tackle this issue. But the symptoms, the initial symptom that I knew about that I could kind of live with, was the external keyboard. The auto repeat would sort of freeze occasionally. When you press the brake key on the external keyboard, you get sort of multiple assertions of brakes that would send the cursor racing down the screen. Things like that. Nothing absolutely show-stopping really. No particular reason to take the board out of the machine, but as I was doing final tests on the system prior to actually dispatching the thing and finishing the job up and settling up with the client, it became apparent that it was also causing, the very presence of this board with this board was causing SIO problems. So that's the serial I/O bus on the Atari. This is, for example, an SIO to PC, which you can plug into the SIO port there. And you can emulate disk drives and whatnot. Obviously you'd plug your disk drives, your cassette deck, all that sort of stuff. Your FujiNet would go in the back of there. Now what I was seeing was intermittent functionality. You were having non-existent devices, serial timeouts, etc, etc. What I initially suspected, which was a fairly reasonable thing to suspect, was connectivity problems with the stack of, basically a stack of sockets here. The PokeyMAX was sitting in this board, which in turn was sitting in a precision socket where the Pokey chip used to be. So there was plenty of scope for problems with maybe boards moving around when they heat up, or the little bits of warp in the board and that sort of stuff. All it takes is one leg to just not be touching properly here, and you're going to start getting problems. So I've spent quite a lot of time last week working on the socket legs, wicking them, adding extra solder onto them, just to make sure that everything was really solid when it was pushed in.
I've had no complaints so far.
And none of that did any good. And the final piece of proof was the fact that this AKI board did not create any SIO problems when the Pokey chip was put back in top of it. And likewise, when this board is taken away, the PokeyMAX doesn't create any SIO problems at all. So both these devices work perfectly well in isolation, but not together, which was very unfortunate. So what I ended up saying to the client was, look, you're going to have to choose between these two devices. It's either PokeyMAX or USB AKI, because you're not going to be able to have a reasonably functional system with them both in the machine at the same time, unless you're actually proposing never to use the SIO bus, because it was completely unreliable. Sometimes it would work, sometimes it wouldn't. So there's obviously some sort of timing upset between these two things here, bearing in mind they're both, you know, doing a lot of, emulating a lot of things, and I would have thought this board would actually stay out of the way of the SIO bus entirely, but it seems not. It has some sort of adverse effect on the PokeyMAX. So the client said, well, it's up to you really which one you think is better, which I found quite confusing actually, because of course my understanding was that the reason this board was on the shopping list for this machine was because its owner specifically wanted to connect a USB keyboard to the computer. Why else would you order or specify a board whose sole purpose, or certainly whose primary purpose, is to allow the connection of an external keyboard to the Atari if you didn't want to connect an external keyboard to the Atari? And of course the tribulations I've had with this board are fairly well publicised in the chats I had with the client, and of course in the videos I made about this computer. One reason I was reluctant to take this board out is because I'd already put the USB connector on the board and cut a hole for it in the back of the case. So we're going to end up with a redundant USB connector if we took this out. But if we left this in and we took the PokeyMAX out, which I already had to repair as well because that was supplied with a manufacturing defect, but it works fine now, we were going to lose stereo, and I would have to reroute the cabling for the stereo output on the SAVO to take the audio from the legacy audio output, which would be mono. So it wasn't really an easy decision. But as it turned out, the client just said, well, take the AKI board out, because I pointedly asked him and I ended up saying to him, look, do you need to connect a USB keyboard to this computer? And he said, no, I don't need to connect a USB keyboard to this computer. He never wanted to be able to connect a USB keyboard to this computer. But somehow this salient piece of information never found its way to me. Clearly I didn't ask the right questions. But this board, the only reason it was in the computer in the first place is because it was deemed to be part of the big build of a powerful system. Now, to my way of thinking, power upgrades are things like the Ultimate 1 MB, the VBXE, the Rapidus, which is a CPU accelerator. That certainly makes for a powerful machine. And maybe the PokeyMAX as well, because that greatly amplifies, no pun intended, the audio capabilities of the machine. You've got SID, you've got Quad Pokey, you've got Covox, etc, etc. So clearly they are power upgrades. This, on the other hand, is a very specific piece of equipment that allows you to do nothing else, in this particular revision of the board anyway, than connect a USB keyboard to the back of the computer. And if you've got no intention of connecting a USB keyboard to the back of the computer, and he didn't ask to be able to connect a USB keyboard to the back of the computer, what on earth have I been told to order this for and put it in the machine? Moreover, there was clearly going to be contention in the Pokey socket. All the other devices that were spec'd up with this computer, none of them get in each other's way. Well, they do get in each other's way in a sense, but I'll mention a bit more about that later on. But these two devices both go in the Pokey socket. So unless you have a specific burning desire to attach a USB keyboard to the back of the computer, bearing in mind this board cost about 35 quid, why put it in the computer in the first place? Now, in fairness to the actual client, he didn't really have any idea what half of this stuff does anyway. He just wanted a powerful computer spec'd up. Now, unfortunately, it wasn't me who spec'd up the powerful computer for the client, because what I would have done is said, what do you actually want to do with it? And I would never have brought this particular device into the discussion unless the customer had said to me, oh, by the way, I'd really like to be able to use an external keyboard, a USB keyboard with this system. And at which point I would have probably said, oh well, you can buy the USB AKI board, but bear in mind you've also got the PokeyMAX, so we've got the consideration of will they both fit under the keyboard, will they cooperate properly together, etc, etc. So this would have been automatically marginal at best when it comes to recommending parts to put in the computer. I guess it's been useful to spend all this time trying to troubleshoot this device and get it to work in this machine, and then trying to troubleshoot operation with the PokeyMAX, and ultimately finding that it was no go. Hopefully that's been useful in some sense, but I don't have any personal vested interest in this device. I don't have any computers that need an external keyboard, and I didn't have any particular vested interest in putting it in this machine. The only reason I was trying to put this board in this machine is because I was asked to purchase it and put it in this machine, and I assumed I was doing so with good reason, because the owner wanted to plug a USB keyboard into the back of the machine, and he'd be disappointed if he couldn't. Turns out nothing could be further from the truth. And all the time spent trying to make this work, trying to make it work with the PokeyMAX and putting the USB connector in the back of the case was a complete and utter waste of time. Totally unnecessary from the start. So serves me right for not asking the difficult questions earlier on, because I could save myself quite a bit of work. And the hours really did rack up on this machine, not least because this isn't the original keyboard that actually came with the computer. Yes, there's more. Last week when the time came, this was prior to actually finally jettisoning the AKI board, when the time came to do the final checks on this computer and invoice for the work and get the thing packed up and sent off, it started to boot to a grey screen. So as you can imagine, the air was blue at that point, and I was absolutely beside myself with rage, given all the hours that already spent actually putting the thing together and making it work. Now, as I mentioned earlier on, for reasons of clearance, what I've actually had to do here is mount the Adaptus board directly to the motherboard. So that board is soldered directly to the motherboard, and I've done that on the original board. The only way to get the ultimate 1 megabyte low enough, since it crosses over the top of this connector here, to clear the back of the keyboard in the 800XL. Depends partly on what kind of keyboard you've got, but in this case it's necessary to have this as low as possible. So that's what I did. It doesn't matter so much about the height of the Rapidus, but this here has got to be low down. So I'd soldered that to the motherboard. Now, when I first got hold of this machine, back in January, when I opened the box rather, it had a 256k RAM expansion in it. And I did notice at the time, before I took away those old upgrades, because I didn't really want a pre-upgraded machine for this project. I wanted a completely stock machine that nobody had tinkered with at all. But of course what I was sent was a filthy, battered up old machine with a crack in the corner of the case and a broken pylon and a keyboard that didn't work properly, and I needed the flex cable replaced, and it was packed in a load of old sweaters and t-shirts. So I was a little bit dismayed when I actually saw that, but of course I worked my magic on the case and dismantled the whole keyboard and gave it a deep clean, and it looks rather nice now. But in any case, what I did notice when I first turned the machine on with the original RAM upgrade, and thereafter when I'd taken the original RAM upgrade away, is that it would periodically, one time out of 3 or 4, it wouldn't want to boot. Now I assumed that this was a problem with a socket, an old socket or something like that. This is all I had to work with. The motherboard I was sent was the one I had to put the stuff in. I wasn't too comfortable about it, but that's what I had to work with. And I gave the board a thorough check over, and generally speaking, it appeared to work okay. Then I started to put the upgrades in it. But there was always a little part of my mind that was wondering why every so often it didn't want to boot up. Well, that basically came and bit me in the backside last week when the time came to actually send this thing off and get it ready for dispatch. Is because it would occasionally boot to a grey screen, and I pretty much traced the problem down to when you pressed on the corner of the board here. If you pressed on the Adaptus board here, that's what would send the computer loopy. So it appeared, because naturally when I soldered this board to the OS-ROM socket, I was naturally very careful when removing the old socket. I visually inspected the traces thereafter and the vias to make sure nothing was broken, because this was kind of a one-time thing, putting a soldered board on the motherboard. But somewhere along the way, some kind of break has appeared in the via. Sometimes it's possible for the top and bottom of the via going through the fibre of the board to crack in half. That can create all kinds of problems if the via is only connected to the trace on one side or the other, especially if it's on the opposite side to where the soldering is going on, because then you never get the solder to go through the gap properly and you get an intermittent fault exactly like the one I discovered. Anyway, so I'm certainly not going to blame my soldering for that problem. I'm going to blame some sort of damage on the board itself, and that would certainly correlate with the behaviour that I experienced before I started to work on it. But whatever the case, anyway, that board needed to come off. I wasn't happy with the state of the OS-ROM socket afterwards when I took that board off. So what I decided to do is go to the spares pile next door and try and find a spare Atari 800XL motherboard that would fit the bill, and I actually found this one. So this is a completely different motherboard. The board as it was lacking a couple of components. It was missing a transistor, it didn't have a crystal, but I put it in the dishwasher, cleaned it up. I had to replace the monitor jack, I've replaced the power jack, I've done some recapping on the board, etc, etc. But it didn't work. And the reason it didn't work was because there was actually a bad inductor next to the CD4050 chip here, so I had to get the oscilloscope out on it to track that problem down. That would have made a nice video in itself actually, because it was an interesting problem. The machine was completely dead as far as video was concerned. But replacing that coil there, that choke, fixed the board. So the next thing I did was prep this board for all the upgrades that came from the other board. But I took extra special care all the way along the line in this particular instance to be damn sure that there was no problem around the OS-ROM area of the board. So I started to install the other upgrades, and I left this part till last, basically putting this Adaptus board and soldering it to the motherboard, because if that went wrong again, or there was a problem revealed itself under here, it was going to be an absolute disaster. But there was no problem at all. So this machine, it's got the same chipset, the same TTL logic, the same upgrades that were in the other board, but nobody tinkered with it before. It was a stock board that was lying in the spares box. It was repaired, I made it work, and then I put all the upgrades in it. It behaves 100% identically to the original board that the owner sent across, with the exception that it no longer has an intermittent problem where it boots to a grey screen. So that's great. So there were a couple of other problems, of course, thereafter. I discovered that both of these multiplexer sockets for the 4051 keyboard chips, they were both brad. They were single wipe initially. They both needed to be replaced because I had problems with the keyboard. But anyway, so the client has got a completely new motherboard, which is 100% trustworthy now. No defects. The only thing that's left that I was sent, in fact, is the bottom case, the top case, and the keyboard. The keyboard's even had a new flex connector put on it. So basically, everything in this project, apart from the keyboard and the case, has been provided by me. Thankfully, I have a reasonably good stock of spare parts here, so that pretty much saved the day. And then it was after that, when I was testing this new installation, that the AKI board has been jettisoned from the equation entirely. Now, of course, this particular system has been in my possession for over 2 calendar months now, and while, of course, I haven't been working on it every single day, for example, it did take me upwards of 8 hours to simply transfer the upgrades from one board to the other. And after all this, basically building two systems, providing a new motherboard, replacing the PIA chip, restoring the case, fixing the keyboard, retrobrighting the plastic, testing the machine, trying to get this to work, failing, fixing the PokeyMAX, doing all the firmware upgrades, making sure the side 3 works properly, testing the O2 fixer, ultimately getting rid of that because it did nothing useful in this machine, the endless private message discussions with the client, with Jakob, the emails to this one and that one about the faulty PokeyMAX, the AKI firmware, discussions about that, testing firmware on the AKI board, none of which I would have been doing for my own purposes. This was all solely for the benefit of this project. After all that, I think I've made about £400, and if I'd spent 16 hours on this machine, that would equate to £25 an hour. But I've spent a damn sight more than 16 hours on this machine. I would say you can probably double it. So yes, it proves expensive, but that's what happens when you spec up a powerful computer with everything but the kitchen sink in it. The upgrades themselves coming to nearly £700, and you send a computer that was pre-modded, filthy, malfunctioning, and this is how we end up basically where we are with a kind of a nightmare, albatross, time drain, rabbit hole project like this, which has only now reached the stage where I'm quite happy to actually package it off and send it back. And of course, as a result of all this time spent, I'm now even further behind with the rest of the work queue, with more work coming in as I speak. So I've left myself in quite a difficult position now. I agreed to build a machine, and I've gone as far as actually providing a new motherboard to make sure it gets completed and that it's reasonably reliable. So I just hope it's appreciated. So anyway, let's plug the keyboard in, plug the side 3 cartridge in, and see what this machine will actually do. But before we do that, it's time for a word from our sponsor, PCBWay. Now, as well as being your first stop for PCB prototyping, PCBWay also offer a PCB assembly service with an instant quote system, a CNC 3D printing service, and they'll even print you a flexible PCB if that's what you need. PCBWay also have a community design section, and one of those community designs is a video board VBXE adapter for the Atari 800, and I'm going to order one and put one together for a customer in an upcoming video, and in so doing I'll guide you through the whole ordering process so you'll know exactly what to expect. So please show some support for the sponsor and visit PCBWay today. Right, so let's switch it on. Now we're looking at the video from the VBXE RGB output here. And as you can see, it natively has the correct NTSC colour palette, the Rocky palette, which has been flashed to the VBXE. So that's nice, so we don't need to waste space in the Ultimate 1MB firmware soft loading the NTSC palette. So in any case, we can see that the thing turns on. So if we hop into the Ultimate Setup menu with the help and reset keys here, we can see what's enabled and what's not. The Rapidus is disabled at the moment. I'm disabled! And the reason we can actually do this is because instead of having the ground wire, which is kind of a switch wire on the Rapidus, connected to ground, which enables the Rapidus, puts it on the system bus, and it exists as PBI device 0, the Rapidus firmware, which is why we've got the device ID of the PBI BIOS on the Ultimate 1MB, which drives the side 3 cartridge. We've put that on device 2 so we avoid any conflict. So yes, so the ground wire from the Rapidus is actually connected to one of the I/O pins on the Ultimate 1MB. So we can turn Rapidus on and off in software. So that gives us 3 modes of operation, if you like. We've got Rapidus completely disabled, off the bus entirely, although it's still sitting on the bus. And therefore it does affect the machine in some ways. More often than not, and this is solely because of the presence of the Rapidus board in this computer, when it's turned off in this manner and you press the reset key, sometimes it gets stuck halfway through the warm reset and you need to press the reset key again. So that is a known behaviour of which the owner is already aware, but I'm making him doubly aware here. The way to fix that is to take the Rapidus out of the machine, which you can easily do. So hopefully it won't spoil the enjoyment of the machine, but that's how it works, and there isn't a damn thing I can do about it, or anybody else for that matter. So we've got the various plugins in the machine. So if we go to the plugin menu, we've got the Rapidus switch. We've got various options here for the PokeyMAX. So we've got dual Pokey set up here. We've got the COVOX enabled. This particular build doesn't have the PSG or the dual SID. Other things we can do, we can change the base address of the VBXE FX core. So we've got full plug-in support for everything in the machine. This is the information page. It tells you a little bit about what we've got in the machine. So we can see that it's version 4.20 of the Ultimate firmware. Plugins, we've got VB, which is the VBXE plugin. The VX one, if that was there, that has the soft-loaded NTSC palette. Side 3, PokeyMAX 2, which also works with the PokeyMAX 3, and the Rapidus plugin. And the plugin version is 2.21. That's the CPU at the moment, 6502C, 1.79 MHz. Video is NTSC, 60 frames a second. Rapidus is disabled. VBXE core is FX 1.26. And finally the PokeyMAX, that gives you the core revision of the PokeyMAX. So that is the revision number, that's the chip size M04, and it's stereo and COVOX. There you go, everything you need to know right there in the menu. So let's turn on the Rapidus for a moment, and we can see how that changes things. We'll power the machine off just to give it a clean startup. So now we see the Rapidus firmware being loaded. This is actually after the OS starts, so that Rapidus load operation is a function of the operating system calling PBI device 0. Which is the Rapidus device, which then in turn bootstraps the firmware for that device. Now we know here we're in the 65C816 operating system, primarily because that one has the margin set to 1, but of course the whole boot procedure was quantifiably faster, because now we are running at 20 MHz. So if we hop in here and we look at the system information page, there we go. It's not exact. The sampling system I used for measuring the CPU speed, it's not 100% accurate, but it's close enough, so we can see that we've identified the CPU as a 65C816 at 21.12 MHz. I mean, whether the system actually runs at exactly 20 MHz or not, I don't know, but there we go. So now we have a system running at 20 MHz. So let's hop into the side 3 loader here, see what we've got on the system, and see if we can run a cartridge. I always go for Ace of Aces for some reason. Let's see if that one works on the faster CPU, and it does. But bear in mind, of course, that this emulated cartridge is going to be running at 1.79 MHz because it's emulated ROM code, and that's the speed that the Rapidus is going to run ROM code. Right, so I've just updated the side loader here and the little command processor, and then I've run the RWCRC test, and this is in 20 MHz Rapidus mode on the side 3, and it's completed without errors. So this is just to demonstrate that before the machine goes in the box, everything worked. Now another interesting thing we can have a go at here is the ZX Spectrum emulation for the Rapidus or 65 C816 machines, but 20 MHz of CPU speed is going to be a big help here. So if we run there's two versions of it. There's a slightly faster but less accurate one, and I think that's the more accurate one. I may have that the wrong way around, but let's have a look at that anyway. Okay, so here's the front end of the emulator. Now, since the side 3 loader has its own, it installs its own fat DOS before it runs the XEX or the executable, we can go into the load program dialog here, and here is the actual fat directory of the files we've got on the SD card. And the one I tried, 3D Tic-Tac-Toe, it didn't like that one, but I'm going to try this one here. and then if we press go, it's got some problems. I don't know, I'm not sure if this is because this is an NTSC machine. I wouldn't be in the least bit surprised if the emulator was written with PAL in mind, but nevertheless it's sort of working. it's getting there. Maybe that's the NTSC VBXE bug that we read about on the Atari Age forum. So maybe that's caught us out here. But press fire. Oh, there's a help key here as well, so that's working well. So this is a Z80 code running on the Atari. So if we press the fire key, it's hard to read this, but oh, there we go. It's actually working. So this is a ZX Spectrum racing game. Probably not going to last very long. Oop. And yes, the joystick input does work. Isn't that incredible? There we go. I'm going to steer left and right. Building a bit of speed up there. That's just amazing. It really is incredible. What an achievement. And I think Conrad wrote this, Draco 30. Very impressive indeed. And as I say, I think the glitches on this are actually probably caused by the VBXE core bug, the NTSC bug. I don't know, I'm guessing there anyway. So that's pretty impressive. Now, of course, a lot of things just don't work at 20 megahertz for reasons entirely unknown. They should work because the software doesn't depend on any undocumented opcodes or anything. But for example, if I try to load the little command processor for the FAT disk operating system provided by the Side 3 loader here, it doesn't load, and I don't know why. These files, meanwhile, do happen to work. So there you go, very strange indeed. That's what happens when we have Rapidus in the machine. Likewise, this loader updater for the Side 3 loader should work fine, but of course it just spectacularly crashes, probably because it's interacting with the Side 3 hardware, as is the rest of the software. So if we go in and turn Rapidus off and reboot the machine, now when we run the command processor, it works perfectly well, and it's quite a small binary, so I don't know what's going on there. No idea whatsoever. So anyway, this DOS works with the FAT file system, and we can run our programs from here if we want. So we can do a read-write test on the card, which unfortunately we can't launch in this manner for some reason at 20 megahertz. And we can do the RWCRC, which I already ran, and as we saw, that passed with no errors. So it's a bit of a crapshoot what actually happens at 20 megahertz. And as I say, it's not because of ignorance of the requirements of the 65C816. I just think things aren't quite there when it comes to, as ever, as has been absolutely characterised this whole project from start to finish, things aren't quite there with device A working with device B. You might get lucky and they might work together. We've already seen that this, the AKI USB, doesn't work with current versions of PokeyMAX, certainly not PokeyMAX 2 anyway. And likewise, we've got unpredictable results with Rapidus, Ultimate 1 megabyte, Rapidus, Side 3, etc. It's going to have to be a case of your mileage may vary when the owner gets this back. He's going to have to play with it. He's going to have to understand, as I've told him repeatedly, that there's certain things that we just can't do anything about. The people who write the actual CPLD code for these devices, they might get their heads together, hash things out, test things exhaustively, and we might end up in a situation where everything works together. I can't do anything about that. That's just the way it is. So we can perhaps hope for software updates and firmware updates in the future, but until then, it is absolutely what it is. So anyway, we can come back out of the command processor, and as far as I can see, things seem to be working quite well. We can run these music files, of course, and I won't play much of that because it'll immediately get a copyright hit. So we've got the music player there, which I need to add things to. Now, of course, since we've got PokeyMAX in the machine, the side 3 loader should be aware of the fact we've got Covox, and yes, we have. It's detected Covox there, D280, so it knows we've got Covox on the machine. And if we go over, have I actually got any Covox files here? It would be nice if I had. Maybe on the other card. See if I've got any Covox files. We'll do .cov. There's one. Let's have a look at this. So this is coming through the Covox player, so we know that works anyway. Hopefully I won't get a copyright hit on this one. It was George Benson playing Straight No Chaser. Something else we can do, of course, since we've got VBXE, is run an 80-column display, and I've put the drivers on here, the SVBXE.sys driver. Of course, we can auto-load these at boot time if we want to. The consys driver, and if I do con 80, we have an 80-column display. There's a driver now that's had the palette corrected for NTSC. I just haven't put that one on here. So anyway, now we've got an 80-column display, and we can go an RW test, which would hopefully be very, very quick. So yeah, 87 kilobytes per second writes and 122 kilobytes per second reads, because of course in this particular instance I'm running at 20 megahertz, so we've got a nice hard disk speed up there as well. So here we've got a high speed hard disk, a nice bump on the hard disk speed there. We've got hardware 80-column display. In any case, I'm fairly satisfied that this machine is as good as it's going to get. It's been reliable all the way through these tests. The few little quirks, as I say, that I can't really do anything about, I think that's going to be common to any machine with Rapidus in it. If you don't want the quirks, don't get the hardware installed, unfortunately, is the only advice I can give at the moment. But I bought the hardware, so it's going in, and it's been paid for. And as I say, it's not a case of, I don't go off on a tangent when I'm working on a project like this. I'm constantly in communication, almost to a fault, with the client, and I think the client will be able to verify that fact. So at any point it's possible, and this is always the case if you send your machine over here for upgrades or repairs, you can step in at any point if you've got a problem, or you want to change the course of what's being done, or you're not happy with the way the costs are mounting up. You can always step in and change the plan, change the way we're moving. You can modify the project or what have you. If you're not happy with it, we'll just send it back to you. That's always been the way I've operated. Now in this case, the client was very, very regularly kept up to date with the amount of work that was going on. You could see it in videos, he got feedback in private discussions. All the while, it was always a case of, John, do whatever you need to do to make it right. Again and again, do what needs to be done to make it right. And of course, I had to say, in some cases, there are certain things that are completely out of my control, vis-a-vis the incompatibility of AKI and PokeyMAX, the various quirky behaviors if you've got Rapidus and Ultimate 1 megabyte in the same machine. Obviously the accelerator would have been a big loss because I'd already bought it and I don't want it, so that's staying in. Hopefully having an accelerated CPU is something he wants to do, and it's a little bit more important than having a USB keyboard, which is something he didn't want to do. But yeah, so every step of the way the remit was to keep going until it was as good as it could be, which is exactly what I've done. But of course the side effect of that is, because I'm not doing this for fun, is that the costs rack up. And I don't actually charge by the hour per se, but I have to somehow quantify the amount of time that I've put into it. Now, the amount of time put into this has just been absolutely preposterously huge. But in this case, the overriding problem has simply been device A not wanting to work with device B, and as we've got a very clear-cut case of that, which I wasted a lot of time on because I never thought to ask the owner, do you actually want to connect a USB keyboard to the computer? And the owner never thought, when he was watching me having a fight with this thing, he never thought to say, well, look, before costs get out of hand, let's just abandon that completely and let's just not put it in the machine. So yeah, it could have gone either way there. I didn't ask the right questions, but I think I made it fairly plain that I was working on the machine, and it wasn't for free. So as a consequence, that's how we end up where we are. I've certainly learned a lesson from this project, and that lesson is not to take an assignment and a bill of materials at face value that somebody else prepared without asking more questions, more pointed questions of the client. Do you need this particular piece of equipment? Do you want the functionality that this particular piece of equipment provides? And particularly so if there's likely going to be a conflict. So there it is. It is now going to be turned off. It's going to go into its cardboard box, nicely wrapped up in bubble wrap, and it's going to get booked up on its final trip to America. So nevertheless, I want to thank the owner, the client, for being very communicative throughout and very understanding of all the work that's gone into it. And of course I want to thank everybody who's watched the video, anybody who's liked it and left comments, etc. And particularly, of course, I want to thank the patrons who really do keep the channel going. They do help to maintain momentum, although of course March has been pretty thin on the ground when it comes to videos, but that's, as I say, a consequence of getting tied up in sort of never-ending jobs. So hopefully I can make that up for that by making some interesting videos of stuff that's in the queue. I've got some unusual machines and unusual jobs in there, which I'm going to film. A client came along just this afternoon actually to drop off a couple of machines. They're not the kind of thing I normally work on, so I think I'll get some of the quicker jobs out of the way, maybe some of the easier jobs first, so that we're left with the more difficult stuff. Just to get the numbers down, because the queue is becoming totally intimidating at this point. It really is, and I do need to crack on with it. With that one, I'm going to go away now and I'm going to box this machine up and book it up with the courier, and that's the last I'm going to see of this one. So I hope you enjoyed it. Thank you again for watching, and I will see you again in the next video. So bye bye for now.